So this was the Norton's theorem. Statement you already know. Steps in solving the Norton's theorem is, first point is remove the load resistance of the circuit. Next point is find the internal resistance, or sometimes it is called R equivalent, or sometimes it is also called R Nortons of the source by deactivating the sources. Now third point is now short the load terminals. Now short the load terminals. Short the load terminals and find the short circuit current. And find the short circuit current. Find the short circuit current, that is what? IS flowing IS flowing through the shorted terminals, flowing through the shorted terminals by using conventional analysis method, by using suitable methods. Okay, so that was the step number 3. The same way, what is step number 4 is? Step number 4 is Norton's equivalent circuit is drawn. Norton's equivalent is drawn by keeping the internal resistance, that is Rn in parallel with the short circuited current, we call it as ISC, or sometimes it is also called as IS. Okay. The next step will be step number 5 is reconnect the load resistance. Reconnect the load resistance. Reconnect the load resistance RL of the circuit across the load terminals. Across the load terminals and find the current through it, and find the current through the load. Current through the load is known as load current. Current through it is known as the load current, IL. Hope you understand this point. Okay. Now let us take an example here. Let us consider an example with this case, where you have resistance R1, this will be resistance R3, another resistance called R2. Here we have a source here connected like this, plus minus source voltage. Here we have a load resistance connected here. Okay, this is what the load resistance, which is varying here in nature. Let us consider this as the load point. Okay. Now, to understand the Norton's theorem in detail, let us consider this circuit here. In order to find the current flowing through the load resistance, in order to find the current flowing through the in order to find the current flowing through the load resistance, in order to find the current flowing through the load resistance, we we will be what? First of all, removing. Go back to the first step. Step number one is what? What is step number one? First of all, we have to remove the load resistance of the circuit, then find the internal resistance of the second point. Okay. Step number one will be follows like this. We have to remove the load and short, make it short. So that implies this can be plus minus Vs. This is the R1, this is R3, R2, and this load resistance is removed and replaced by short. Okay. Then I want to find the current flowing in the circuit is found out by this equation is, let me write this equation as, how we will be finding the total current? I can also be written as I is equal to, yes please, how do we frame this equation? I is equal to what? Total voltage divided by total equivalent resistance. What is total equivalent resistance here? Equivalent resistance is equivalent to this R1 is in series with the parallel combination of R2 and R3. Yes or no? R1 is in series combination with the parallel of R2 and R3. Hope this point is clear to everyone. Okay, I want to find the current flowing through this path. Yes or no? IL is equal to what? So for that reason, I want to find the current flowing through this path means I can apply the current division here. That is IL is equal to total current into current flowing through this path I want to find, right? This and this will be one in the sense same. So to find the current flowing through this R2, what is opposite resistance? We have R3 divided by R3 plus R2. Hope this point is clear to everyone. Okay. That is what value of IL. If you replace all these values, finding the value of IL, now the short circuited is removed and the independent source is deactivated. The internal resistance is calculated. As you can see here, this is the internal resistance. Okay. Now replace all the values in the circuit. Then circuit will follow like this. So that implies IS, this is R Norton's, and this will be the load resistance RL, and the current flowing through this path is IL. Okay. So therefore IL is equal to IS into Rn by Rs plus Rm.